For this part of the lab, we're going to study how different solutions are affected by adding a strong base. So the strong base that we're using is NaOH. And what we're going to do is we're going to measure the starting pH of our solutions, and then we're going to add 10 drops of that NaOH to each of those, and we'll measure what the ending pH is to see what effect adding that strong base has. So first we've got distilled water just to act as a standard, so you can see, what's the pH of distilled water, what's the pH of it after we've added some strong base to it. And then we have got a solution of acetic acid and acetate ion, so HC2H3O2 and C2H3O2 minus. Of course, that means there's a cation in there as well, but that part shouldn't have an effect on it. And then we have a solution that contains dihydrogen phosphate ion, H2PO4 minus, and hydrogen phosphate ion, so HPO4 2 minus, another conjugate pair. And then we have HCl and Cl minus, and so that's another conjugate acid base pair, HCl or hydrochloric acid and chloride ion. Okay, so we're going to test each of those. Now, how we're going to test the pH, we're going to kind of do more of a rough test. We're not going to use a pH meter. We're going to use what's called hydrion paper. And so this gives us a color change. When we put the solution on the paper, it'll turn one of these colors, and that gives us an idea of the approximate pH. Of course, this only goes up to 12. So it doesn't bring us all the way up to 14, but that's okay. We're just going to get estimates of the pH so we can get a general idea of where did we start and where did we go. And then from those pH values, we can actually quantify the approximate hydrogen ion concentration or hydronium concentration in these solutions, and understand a little bit about how much the different combinations affect how much that changes. So let's start with our distilled water. So I've got a piece of pH paper, 2 pieces for each of these solutions. And so I'll go ahead and just put a drop of this distilled water onto this first piece of paper. So you can see it doesn't look like it has changed much. Now, of course, these are always going to look a little bit darker because they're damp, but in general, if you look at that and compare it to the scale here, since it's just distilled water, I can just pick it up. Now, this to me looks pretty close to that it's reading as a 6 on here. It's a little darker than the 7, so we're going to call that 6. Again, you have to realize this is a rough estimate, so distilled water is probably a little closer to 7, but we'll call it 6 because that's what the pH paper is giving us. Now, let's see. Next one we have is our acetic acid and acetate ion. And so that, again, I'll put a drop of that on here. And then let's take a look what that looks like. Now that one looks a little bit darker than this first one. So again, this one I called a 6. This next one, I would say that that's closer to a 4. And so we'll call the starting pH of the acetic acid and acetate ion a 4. And then let's do the dihydrogen phosphate and hydrogen phosphate ion solution. Okay, now this one looks lighter than the others. So this one's starting to get a little more yellow than the others, but you could still probably call that a 6. It's not quite a 7. So we'll say that one is also a 6 to start with, just like the distilled water was. And then let's see, we have our HCl and chloride ion solution. And that one's very different than the others. And so that one definitely starts at a very bright pink. And so that one starts at really like a 1. Okay, so we've got our starting pHs. Now what we're going to do is we're going to add NaOH. We're going to add 10 drops to each of these. So just kind of move this closer. Get this dropper out of the way. Okay, so now we have our solutions with the added NaOH. I'll kind of swirl each of those. I can stir them a bit with the droppers as well. But then we're going to measure the pHs of those two. So since there's a little bit of liquid in the dropper, I'll kind of suck some of this up and squirt it out several times to mix it. Okay, so those are all mixed now. So again, we will put a drop of each on the paper. Oops. There we go. So now this one had a big change. This one now is a pretty dark blue. And so it could be somewhere from 11 to 12. It's actually closer to the 11. And so that pH went from a 6 to 11 by adding those 10 drops of NaOH for the distilled water. Now, the acetic acid with the acetate ion. Let's see what happened to it. Okay, so now that one doesn't look like it had a big change. And so that I would still call that a 4. And so it actually held constant. It started at pH 4 and it's still at a pH 4. And then the dihydrogen phosphate ion and hydrogen phosphate ion. Let's see. Now that one, that still looks like about a 6. And so that also started as a pH of 6 and ended at a pH of 6. And then let's see our HCl and Cl minus. Okay. Now that still looks like it's a 1. Okay.